Good evening, Gary Ritchie here for Pharmaceutical Manufacturing Magazine. I'm here with Dr. Ralf Marbach, Chief Science Officer of VTT of Finland. Ralf, it's good to see you.
Hey,
we're here at IFPAC 2009. You know, it's been a couple of years now that you've become quite well known for this thing they're calling science-based calibration. We need to know a little bit more about it. Fundamentally, what you think it is, what problems you think it can solve, and maybe a little history. How it got to travel this far, and now we're in the United States with it. You started with it in Finland.
Wow, many questions to answer in a minute. Okay, well, let me try. Basically, what it is a matched filter. The same thing that you are carrying around with you in your mobile phone several times. It's basically that for spectroscopy. It's a matched filter. And it is a matched filter because basically spectroscopy, or I should say chemometrics, is a part of signal processing. It is the mother discipline of chemometrics is time signal processing. It is not statistics. Statistics is a sibling, but the mother is time signal processing. And you can apply the same principles and have the same advantages that they are also using in electronics, also for multivariate spectral data. That's basically what it is. And you save a lot of hassle, and it has been used within VTT mainly for instrument building, I would say, on a routine use now for, I don't know, 4 or 5 years now at least.
I see. What practical applications do you see it for pharmaceutical and the QBD? I understand, it's being said that, you can do the calibration without relying on the reference values. This has interesting implications.
Well, I mean, okay, actually what it all turns down to is that if you take a mathematical magnifying glass, so to speak, and you look at the details of all the various algorithms out there, PLS or classical or PCR or factor selection or pre-processing, whatever the details are, if you look at it under the mathematical microscope, you see that they all these methods use the same basic formula, and it's always a function of only two things, the spectral signal and the spectral noise. And the only difference that is between all of these various things is what is used as spectral signal and as spectral noise. And so what I'm basically saying is, since it is only these two things, go at them directly. It saves a lot of hassle and makes the thing transparent.
My simplistic understanding then is what's left over between the signal and the noise is the residual.
There is signal or noise and nothing
and that's
else. That's it. Only two things. Yeah.
So, how did it get to travel this far around the world now? I mean, you started out with this idea quite a few years ago in Finland, and now you're over here in the U.S.
Well, like I said, it has been used actually in VTT for a number of years, because actually there is dramatic cost saving when it comes to instrument design. If you design an instrument for a specific application and you want to know if you need that extended wavelength range or no, right? Yes or no? Yeah. Then do you need standard InGas? Is that enough, or do you need to pay the more for the extended one? Then so far there has been or prior to that, there has been no way to say that conclusively. But since once you break all those details away and you go to the basic simple formula, you can directly actually write down the general definitions of what multivariate specificity is and what multivariate sensitivity is from these two simple things. And it's unfortunately not published yet, but and then you see, okay, do we have to do it or not? How much do you need? Boom. And then we can decide, and it saves a lot of money in instrument building. So that was the basic reason. And now also on the application side, people are trying to, are trying it out, and some have picked up, and those that have are quite enthusiastic.
Where do you see the future for this application? I know you're an advocate of it, and you're pushing for its use strongly, at least in the pharmaceutical because of the QBD needs. But as you said, it's got use beyond pharmaceutical.
Yeah.
Absolutely.
Outside Moha, yes.
Well, this is exciting. It's good to talk to you.
It was my pleasure.
And we hope to hear more about this application in the future.
I hope to be here next year.
Great.